Welcome to week 16 for Algebra 2. Please make sure to fill in your table of contents. For my regular Algebra 2 class, your warm-up will look different from this warm-up that's pictured on this page. Be sure to also check your warm-up when you're finished with it and ask any questions that you may have. You may either get a sheet of paper for this first part, or you're going to need Student Journal 58, Student Journal page 58. On the front of Student Journal page 58 is a big space at the bottom where it says Notes. You are welcome to go ahead and put this information on that or in that space. So it's up to you, whatever you prefer, a piece of paper for this beginning information or the front of Student Journal 58, which would be Student Journal page 57. We're going to be completing the square. Why are we going to be completing the square? This method allows us to use the square root method to solve quadratics. How? You rearrange your quadratic so that it looks like this. ax squared plus bx plus, we're going to have an empty space here, equals c, along with another empty space that we're going to add something there. So you really should make sure to include this plus an empty space. First things first. A has to equal 1. It says A does not equal 1. Oh, if A does not equal 1. Sorry about that. Brain lapse for a moment. So if A does not equal 1, if this A value here, let me highlight it. If this A value right here is not 1, then you need to divide everything by that A value to make it equal 1. So that's the first thing you need to do. Check to make sure that your A value is 1. If it's not 1, divide every term by A to make it equal 1. And I guess I should have put squares instead of blanks. In the squares, that's why it's called complete the square. In the squares, you're going to write this value. Now here's what you're going to do. You're going to take the B value, divide it by 2, and square it. That's the value that you're going to put in each blank when you're completing the square. And I'll show you an example so that you can see what in the world I mean by that. For number 3, you can rewrite the left side as a binomial squared. And you'll have x, and then inside with x you'll have something, and I'll show you what that is in just a moment, equals whatever value or number you got over here. Step 4, you'll take the square root of each side. Don't forget to put your plus or minus sign. And we're going to solve for x. We're going to solve by completing this square. So I am going to first add 24 to both sides. I'm going to have 2x squared plus 12x plus my square equals 24 plus my square. And I really should have done this first. So if you think about this, really I think number 1 should be to check your A value. Now if you notice, my A value is not 1. So I'm going to divide both sides by 2. And I don't really have to divide my box by 2, so I hope that makes sense. And don't divide your box by 2. There's nothing there. And I'll say that when I divide here in just a moment. 2x squared divided by 2 is x squared. 12x divided by 2 is 6x. Nothing in the box divided by 2 is still nothing. Equals 24 in the box, 24 divided by 2 is 12, plus nothing in the box divided by 2 is still nothing in that box. Okay, step 2. In the squares, you're going to write b divided by 2 squared. So the C value. That's what this is. This is your C value that you're trying to, the constant that you're trying to add to both sides. So the constant I'm trying to add to both sides is going to be my B value of 6 divided by 2 and square it. 6 divided by 2 is 3. 3 squared is 9. 9 is going to be what you put in the box on both sides. Now, the whole point of completing the square is this. You are creating a perfect square trinomial. This trinomial right here is a perfect square. What that means is when you factor a perfect square trinomial, it factors into a binomial squared. Here's the quick and fast and easy way to get this factoring. First of all, your middle variable will go there. Next, the quick, fast, easy method that will work every time, and if you know me, you know I'm not much for saying, yes, this works every time, but this does work every time for this one. The quick and fast, easy way to know what goes beside of your x is it's the answer that you got when you divide it by 2. That's what goes here. Is that a positive 3 or a negative 3? Well, that's a positive 3. So x plus 3, the quantity squared, is x squared plus 6x plus 9. Let me prove it to you really quick. You don't have to write it down, but I'm going to show you. X plus 3 squared means x plus 3 times x plus 3. I'm going to distribute. X times x is x squared. X times 3 is 3x. 3 times x is 3x. 3 times 3 is 9. Combine your like terms, x squared plus 6x plus 9. So yes, that does absolutely work. And then it's going to equal 12 plus 9 is 21. The next thing that I will do is take the square root of both sides. The square root of x plus 3 squared is just x plus 3. Don't forget that plus or minus. And then 21 is positive, so I don't have to take out a negative sign. The factors of 21 are 1 times 21 and 3 times 7. None of those are perfect squares, so it's simplified. And I'm going to subtract 3. X will equal negative 3 plus or minus the square root of 21. That's the answer to my example here. Now, if you'll flip your paper over to Student Journal 58, we'll do the problems on that page. We're going to do questions 1 through 3 during week 17. And I'm going to talk about 4, 5, and 6. This is a very common question that I have seen on the SAT. Find the value of C that would make this a perfect square trinomial. All this is asking you to do to find that C value is to do your B value divided by 2, that quantity squared. Notice every single A value is 1. On the SAT, the questions that I have seen, and all the practice, all the release tests, on that SAT, the A value is 1. So all you have to do is take your B value, divide it by 2, and square it. And that is the C value that gives you a perfect square trinomial. So C will be negative 14 divided by 2 and square that answer. Negative 7 divided by 2, which I do not want a decimal, so leave that as negative 7 over 2. Square each of those. That would be positive 49 over 4. That's what C would have to equal to make this a perfect square trinomial. For number 5, C would be 17 divided by 2, that quantity squared. That would give me a fraction if I did 17 divided by 2, so I'm going to leave it. 17 squared is 289. 2 squared is 4, and that will not reduce. So that is my answer for number 5. For number 6, my C will be B divided by 2, that quantity squared. Can you divide 24 by 2? Yes. 24 divided by 2 is 12. Square that quantity, you get 144. So to have a perfect square trinomial, you would have to have C to be 144. Moving on to the next examples, they're still on page Student Journal 58. We're going to solve these by completing the square. So I'm going to use that same method that we started with. Number 7, and I am going to make sure that my A value is 1 first. I'm going to kind of swap those two steps. That'll just save us a little extra writing. Our A value is 1 here on number 7. I'm going to move the 2 to the other side. I'm going to put plus a square on each side, add 2. The C that goes in the square is going to be -6 divided by 2, that quantity squared. -6 divided by 2 is -3 squared. So that's going to be 9. R squared minus 6R plus 9 will equal 2 plus 9. Factor the left side. That will factor into a binomial squared. R, and then don't forget the quick and easy way is the answer you got when you divide it by 2. So that's going to be -3. R minus 3, the quantity squared, equals 11. I'm going to take the square root of both sides. We'll take my final answer up here. R minus 3 is going to equal plus or minus the square root of 11. 11 is not a perfect square and does not contain a perfect square. So I'm going to add 3 to both sides. R will equal 3 plus or minus the square root of 11. That's the answer to number 7. Let's do the same thing for number 8. My A value is 1, so I do not need to divide anything. I'm going to move the 28 to the right side by subtracting 28. So x squared plus a square equals -28 plus a square. Take the C that goes inside the square is B divided by 2, that quantity squared. So 10 divided by 2 is 5. 5 squared is 25. Factor the left side. It factors into a binomial squared. Use your middle variable. Use your answer that you got when you divided by 2. That's what goes here. So that would be +5. -28 plus 25 is -3. Take the square root of both sides. X plus 5 is going to equal plus or minus the square root of -1 times the square root of 3. I'm going to do two things at once on this next one. I'm going to subtract the 5 and simplify the square root of -1. I think I can have space right here. So x is going to equal -5 plus or minus I times the square root of 3. Now number 9, I know I haven't left myself much space, but I think I can kind of work around. You want to get rid of those parentheses. You don't want to leave that there. So we do want to distribute y squared plus y plus a square equals 3/4 plus a square. The C value that I want to put inside that square, the constant that I want to add to both sides, is going to be B divided by 2, that quantity squared. 1 divided by 2 would give me a decimal, so I'm going to leave it. I'm going to square 1. I'm going to square 1, and then I'm going to square 2. So 1/4 is what I'm going to put in the squares. Y squared plus y plus 1/4 equals 3/4 plus 1/4. Simplify, factor on the left. It factors into a binomial squared. Use the middle variable. make sure to use the answer you got when you divided by 2, which is this. So plus 1/2 goes inside there. Equals 3/4 plus 1/4 is 1. Take the square root of both sides. Y plus 1/2 equals plus or minus 1. Square root of 1 is 1. Subtract 1/2 from both sides, so negative 1/2 plus or minus 1. I don't have a radical, so I should write my two answers. That would be negative 1/2 plus 1. That's one value of y. And negative 1/2 minus 1. That's another value of y. So y is going to equal 1, or y is going to equal, this would be 2 over 2. Negative 1/2 minus 2 over 2 would be negative 3/2. So my two answers are negative 3/2 and 1 for question 9. For question 10, I do notice that I do not have my a value to be 1, so I'm going to divide everything by 2 to make it 1. I'm going to add the 3 to the other side. You want your constant to the other side so you can make a perfect square trinomial here. I'm going to find the new constant that's going to go in the box by taking the b value divided by 2 and square it. B divided by 2 is 4. 4 squared is 16. I'm going to factor the left side into a binomial squared. T plus 4. Remember, it's what the answer you got when you divide it by 2. T plus 4 squared equals 19. I'm going to take the square root of both sides. I'm going to come way down here. I'm going to have t plus 4 equals plus or minus the square root of 19. I'm going to subtract 4 from both sides. So t is going to equal negative 4. Remember, whatever you subtract, put in front of the plus or minus. Negative 4 plus or minus the square root of 19. Those are the two answers to number 10. Number 11, I need to distribute first. So I'm going to distribute 3x times 2x is 6x squared. 3x times 10 is 30x equals negative 24. I have to divide everything by 6. So I'm going to have x squared plus 5x plus a square equals negative 4 plus a square. I am going to find my new constant by dividing my b value by 2 and squaring it. So that would be 25/4. I'm going to add 25/4 to both sides. That's going to be negative 16 over 4. I'll need that in just a moment. I'm going to come down here. This will be number 11 continued. And I'm going to factor the left-hand side into a binomial squared, middle variable of x. The answer I got when I divided by 2 is 5/2 equals negative 16/4 plus 25/4 is positive 9/4. I'm going to take the square root of both sides. X plus 5 over 2 equals plus or minus. The square root of 9 is 3. The square root of 4 is 2. I'm going to subtract 5/2 from both sides. So x is going to equal negative 5/2 plus or minus 3/2. So I'm going to have negative 5/2 plus 3/2, negative 5/2 minus 3 halves. Negative 5 halves plus 3 halves is negative 2 over 2, which is negative 1. Negative 5 halves minus 3 halves is negative 8 over 2, which is negative 4. Those are my two solutions for number 11. And I sure don't have much space to do number 12. I might be able to divide, like donate that space to the right of my squiggly line for number 12. We'll see. All right, I need to move this x squared to the left, move this x to the left, and move 28 to the right. I'm going to do all that at one time. I'm going to subtract 3x squared. I'm going to subtract x and subtract 28. Now that looks like a mess, I know, and I'm so sorry. 4x squared minus 3x squared is x squared. Negative 5x minus x is negative 6x. I can go ahead and put my plus a square equals negative 28 and put my plus a square over here. My new constant is going to be b divided by 2, that quantity squared, which would be negative 3, that quantity squared, which would be 9. That's what goes in the box. X squared minus 6x plus 9 equals negative 28 plus 9. Next, I'm going to factor the left side into a binomial squared. X minus the answer I got when I divided by 2, which is 3, equals negative 28 plus 9. Is that negative 19? Yes. Take the square root of both sides. I'm going to get x minus 3 equals plus or minus the square root of negative 1 times the square root of 19. I'm going to finish with two things to simplify. I'm going to add 3 and take the square root of negative 1 and put I. So x is going to equal 3 plus or minus I times the square root of 19. And that's the answer to number 12. And this is a total train wreck, and I'm so sorry, but I think it'll be okay. You know, you can always rewind and see the spaces that you need to see. Now let's look at number 13. Explain how the expression, the quantity 4p plus 1 squared, plus 8 times the quantity 4p plus 1, plus 16 is a perfect square trinomial. Then write the expression as a square of a binomial. Okay, here's what I'm going to tell you. First of all, if you let x equal 4p plus 1, then this could be rewritten as x squared plus 8x plus 16. Now, how do I know if that trinomial, that new trinomial, is a perfect square trinomial? Is 16 your constant? Is it 8 divided by 2 squared? That's the question. Let me highlight that really quick. That is my question. Is this equivalent to this? 8 divided by 2 is 4. 4 squared is 16. Yes, they're equivalent. So that means that x squared plus 8x plus 16 is a perfect square trinomial. I could go ahead and factor that the way it's written right now. I can factor it into a binomial squared, use the middle variable x, and then the answer that you get when you divide by 2 would be plus 4. Now that would be this trinomial that I have rewritten. That would be the square of a binomial. But I have to replace this x with 4p plus 1. What would this simplify to? Do I have like terms inside the parentheses? So my final answer is going to be right here. I don't have anything to add with 4p. 1 plus 4 is 5. That would be the original expression written as a square of a binomial. Hope that makes sense. Let's look at the remainder. I think those are all the problems we have to do for this week. There's your assignment for the week. It's from your textbook. Check your answers in the back of the book. We will have our assessment. There's your checklist to make sure you're finished. and the remainder of the PDF are your answers that you need. Hope you have a wonderful week, and please reach out if you have any questions at all. Thank you so much.